Okay, lesson 9.1. Actually, a review of what we did in chapter 3. In chapter 3, we talked about direct variation. We're going to do that again. Direct variation is simply of the form y equals k times x. We can say y varies directly as x, or that y is directly proportional with x. The constant of variation is represented as k. So that we've talked about before. Today, the new material, at least part of the new material that we're looking at, is that y varies inversely with x, or to say that y is inversely proportional with x. That's going to be of the form y equals k divided by x. And so we either have y equals k times x, which is direct variation, y equals k divided by x, which is inverse variation. In both cases, k can be negative. In both cases, k can be a fraction or a decimal. K is just going to be a real number. So let's very quickly take a look at 5 quick examples, just stating whether we have direct variation, inverse variation, or neither. For example 1, this is going to be direct variation. How do we know? Well, y is equal to k times x. Your k, which is a real number, happens to be 2. For example 2, this is neither. It's very tempting to think that it's actually direct variation because there is a multiplication of 5 times x, y equals 5 times x, but there's more. There's an addition of a plus 6. We can't have that. So if we have direct variation in its simplest, purest form, it's y equals some number times x, and that's it, nothing more. For number 3, let's get y by itself. Let's divide both sides by x. We could see y is equal to 10 divided by x. You can see, just like we have up here, this is inverse variation. We have a number divided by x. Very similar for number 4. We could divide by x once again. Remember what we had just mentioned previously, that k may be a fraction. We're seeing that here that is the case. This is inverse variation. For example 5, this would be direct variation. You can see that y is equal to some number times x. That number just so happens to be a negative. Okay, well, more often than not, what we will see is a problem where we actually have to write a particular equation. The variables x and y vary inversely. As soon as we see that, we may write y is equal to k divided by x. We need to find out what k is, however, and we'd like to write our equation in that form. So our y is a 4. We're going to substitute that value in. Our x is a 3, and we would like to solve for k. Doing that, we will multiply both sides by 3, and then come up with k is equal to 12. We will stop, however, by writing y equals 12 all over x. You might remember y is equal to some number divided by x. We found what that number is. It happens to be 12. Okay, for example 7, let's take a look at this. We can see the time, we could call this t, required to empty a tank varies inversely with the pumping rate. So time varies inversely with the rate. Let's call the rate r. From the very beginning, and this is our answer for part A, where we're going to write an equation, t, the time, is k divided by r. Varying inversely will always involve a division, k divided by a certain variable. The rate is 70 gallons per minute, so I could say r is equal to 70. and it takes the pump 20 minutes to empty the tank. That means T is equal to 20. Substitute T equals 20. Substitute your R is 70. Tell you what, let's multiply both sides by 70 very quickly. And you will get that K is equal to 1400. Now, of course, we're not done. We need to say that T is equal to 1400 divided by R. For part B, the question says, describe the change in time to empty the tank as the pumping rate increases. Well, real quickly, let's just assume that R might be 10, just to consider this. We'd have 1400 divided by 10. T would be, of course, 140. What if our rate increases up to 100? Well, we could see that T is equal to 1400 divided by 100. These two zeros will cancel out. You'd get T is equal to 14. We can see that time decreases as our rate is increasing. So the rate is increasing, it's going up, and yet our time is decreasing. We see that very often with this inverse variation. Let's very quickly go to the second page. You're almost done. Joint variation. Joint variation occurs when a quantity varies directly as a product of two or more quantities. So we'll get direct variation, but with a multiplication of another variable. So for example, if I gave you Z is equal to K times X times Y, that means that Z varies jointly as X and Y. We still have a constant. It's just that we have one additional term multiplied. Here we have a table that will give us a few different types of variation. What the English sentence is written as, and relating an equation to that. Y varies directly with X would be Y equals K times X. Y varies inversely with X, K divided by X. Jointly, Z varies jointly with X and Y. Well, it's direct variation with X and Y. Z equals K times X, Y. Notice the next phrase. Y varies inversely, but with the square of X. So Y is equal to K divided by X squared. And finally, Z varies directly with Y and inversely with X. You can actually combine those two together and get direct variation with Y and then inverse variation with X. Real quickly, let's just take a look at a final problem together. The intensity Y of sound, so we'll say Y, varies inversely, so I'll say K divided by the square of the distance D, so we'll have that's all over D squared from the source of the sound. And what we can see is that with a distance of 1 meter from the stage, so D is equal to 1, the intensity of the sound, that's Y, is 10 watts per square meter. We'll ignore the decibels for a minute. We could have worked in decibels as well, but we'll have Y is 10. This is K all over 1 squared. Of course, 1 squared is just a 1 itself. We have K is equal to 10, and this means Y is equal to 10 divided by D squared. For part B, it says you are 15 meters from the stage. That's D is equal to 15. Well, let's use this equation that we just found and work that out. Y is equal to 10 divided by 15 squared. That's 10 divided by 225. So Y would equal 0.04 repeating. We can see that our units will be watts per square meter, and that would be the sound intensity. For homework, we're going to be doing the following assignment. We'll be working on page 469, 20 through 36, the evens, and then 40 through 46 the evens. Best of luck to you.